What's going on YouTube? Today we're going to talk about signature evasion, or the second part of signature evasion techniques. Previously we talked about obfuscation techniques and the first part of signature evasion. In this video we're going to wrap all of the obfuscation techniques we have learned in the previous videos and apply them on a practical scenario. So let's summarize what we have learned so far. So the first thing, one of the first techniques to obfuscate a code is object concatenation. We learned that in the obfuscation techniques room. So object concatenation. And the next technique was changing object names. So object names, we change them from recognizable names in the English dictionary into something that's random. The third technique was changing the compilation mode. So the compilation mode, let's name it compilation mode first. And we focus on the point that we have to make it release build. When you compile the code, compile it on release. So object concatenation, changing object names, compilation mode, and the fourth one was data splitting and merging, such as splitting the strings, merging variables. This is also part of obfuscating code. And the last one will be, or not the last one, the fifth one is removing, or let me call it stripping the binary or the executable from symbols. And if you remember, guys, we used a tool called strip, okay, dash strip dash all, and the file name or the file in question after compilation. So we apply stripping after we compile the binary. Object concatenation before compilation, so before compilation. Data splitting and merging comes before compilation as well, and stripping from symbols after compilation. So here let's put this after compilation. So here is one, and changing the compiling mode after the compilation. Okay, there is still last one, which is the most important. So the last one, I'm gonna open a new page for this one. Dynamic loading. So what do we mean by saying dynamic loading? Dynamic loading is a technique that's used to avoid something called the IAT. IAT stands for import, okay, address table. What does IAT contain? IAT contains the list of all functions and their addresses. What are the functions here? These functions are called by the program. So by using dynamic loading, what we're doing, we are avoiding the use of AAT, or the address or import address table. So import address table is used by Windows Loader or Windows.h. So basically all of the functions and their addresses are loaded into IAT and then by the Windows Loader. And that's how antiviruses can detect the malicious API calls. When there's an API call to a malicious function, the binary or the antivirus engine can look at the IAT and find out the malicious functions. When we use dynamic loading, guys, we avoid the use of AAT and minimize the exposure to the Windows Loader. But it comes at a price. for every function, we have to look at the documentation in Microsoft and write a single call for that function. We're gonna give an example on how to perform this. So given all of these obfuscation principles, guys, and techniques, we're going to apply them on a practical scenario in TryHackMe. So this is the room, and this is the last one. So we have this code. Okay, we're required to apply all obfuscation principles on that code. As you can see, we have to hide the suspicious library calls. We have to also hide the functions, making sure no linked function or variable names. File hash is different than the original hash, and binary bypasses most common antivirus engines. And that's how technically you perform antivirus evasion. You have to do it at the source code level. You have to apply obfuscation principles, then your binary has a chance at evading antivirus engines. So let's split the view. Now, for task 4, we solved this in the last video, I guess. Okay, task 5, it's so easy, guys. What you have to do, connect to the machine, okay? Grab a copy of this binary, go to CyberChef, okay, and from here you have to upload the file, choose the file from the machine, and then choose this Shannon entropy. So upload the file, choose Shannon scale, and it will give you the Shannon entropy for the shell, and this is the answer. Now for task 6 is also straightforward. You're gonna apply the dynamic loading. Guys, on this code. So this is the code. You have to hide the suspicious API calls by applying dynamic loading. So what you're gonna do, you're going to first take the structure definition, put it before the main function here, and then to load the library and the process or the API call, you have to load them after the main function. Compile the code and you will get the flag. So now we're interested in solving the last one. Okay, so let's see what happened with the machine. I'm gonna just restart everything. Okay, so let's name the code as challenge. So in here, sudo name challenge. Alright, and let's copy the code. Okay, so this is the complete code. Alright, let's now apply the obfuscation techniques on the code. After we apply the obfuscation techniques, we're gonna upload the code to the machine IP address, the web server here, and we should receive a connection on the attacker machine. So in a separate tab, let's open another tab. Ifconfig. So this is the IP address of the machine. Let's take the IP, and on the code, scrolling all the way down. So here we're gonna change the IP address. This will be your IP address, the attacker IP address, and down here the port will be also, let's say, 4545. So going back, and we're going to open the listener. All right, great. So the first thing, guys, we change the host and the port parameters to point to our machine. Okay, the next thing we're going to do, we're going to change the object names. The objective here is we don't want to trigger the antivirus engine to catch commonly used names, object names, or functions in malicious executables. For example, as you can see, the function name run shell. The word shell is commonly caught by antivirus engines, and of course triggers the antivirus engine to raise an alarm. So we're going to remove the shell from here. Be sure that when you change any name, object name, function name, to change all of the occurrences of that function. So now I change the function name to run. I'm gonna have to scroll down and see any call to that function and change it to match the name I have used. So let's scroll down. I think I'm gonna have to make this to zoom out a bit because the code is becoming too close. Okay, scrolling down. So here we have a call to run shell. We're going to change the call to run. Okay. All right. So I think if we copy the code to a text editor other than Nano, it's going to be way much easier to change on it. Okay, so this is the code in Sublime. It's going to be much easier to edit the code here. So right now we edited the function name and changed that from run shell to run. Let's see if there are other occurrences of run shell. So we have one here. Let's change that. So only 3 occurrences and all of them have changed. Fine. So we changed the function name now. Also, as you can see here, guys, a C2 server and a C2 port. Using the word C2 for variable names, especially when it comes to server and ports, is commonly actually caught by antivirus engines. So you're gonna have to change the C2 here to something else. Maybe we can remove it altogether. It's gonna be much easier. So server and port. We can also change all of the occurrences. So run C2 in the search. So we have one here. Search again. Change the C2 here for the port. We have also one here and one here for the port. So no C2 again in the code. Fine. So we change also here the name of the arguments, server and port. Okay, let's see if we have to change other object names. So we have this one, printf. Okay, the printf, we're going to remove this one because it's kind of data leak. So we're going to remove the printf statement. Okay, and here, as you can see, guys, the process, definition of process equal to the command prompt. Now the command prompt process is also commonly caught by antivirus engines. We're gonna have to change this. Maybe we cannot change that because we need to spawn the command prompt. So what we're going to do, we're going to apply data splitting and merging. So instead of that, let's remove this, okay, and define, say, p1. Now p1 will equal to, let me explain to you guys. So basically it is here cmd.exe, right? That's how it is supposed to be. We're going to split the cm, okay, and the d.executable. So it's gonna be like 2 objects. The first one will only be cm, okay, and the next one, say p2, will equal the rest of the value. So d.exe, and then we're going to concatenate both of them in one object using strcat because we're dealing with C code here. Okay, so from here we have p1 and p2. So we have here, as you can see, guys, applied concatenation, object concatenation, and splitted the value to 2 variables or objects. Okay, so up until now, what we have done, we have changed function names, we have changed variable names, of course the ones that would trigger the antivirus engine alarm, and also we have applied concatenation and data splitting on this object. Now we have to apply, as you can see, dynamic loading, meaning we have to avoid using the import address table when we perform API calls. For that reason, we're going to take the section in the walkthrough here. So here's the structure definition. We're going to take this for the API calls. and of course make sure to paste this before the run. Okay, or that's where we write the structure definition of the API calls, of course the new definition. And after that we have to copy as well the pointer addresses. The pointer addresses should come before the main function. But as you can see here in the note, please note the structure definitions should be outside of any function at the beginning of your code. We have done that. The pointer definitions should be at the top of the run shell function. The pointer definition should be at the top of the run shell function. So it's going to be here. This way it looks kind of okay, correct. All right. So after that, we have to match the names of the calls here to the names of the objects mentioned in the code. For example, as you can see, we have the call WSA data. In the pointer addresses here, it is my WSA startup, my WSA data. So we're going to change all of these as well. So we have my WSA startup. It's going to be my, okay. You're going to take this and search for all of the occurrences. We have one. Okay, so we change this in the code. All right, the next thing we're going to change is the WSA socket call. So here we have it, it has to be my. Okay, and what else we have? We have the connect. So we're looking to change the ones in our code. Here's one. Change it to my. Okay, close socket. We have one here. Change it to my close socket. And clean up. Let's search for WSA cleanup as well. Okay, so we changed all of these to the corresponding values in the pointer addresses. So what else we have to change? Let's see here. Socket, my socket. The socket is defined here. Let's see. It's defined in the definitions. So we might have to change this as well to something else, depending on the pointer addresses here. So let's change that to something else. Let's say S0. I will change all of the occurrences as well. So from my socket to S0. Again, we have one here. S0. You can pick up any name you want. It doesn't necessarily have to be S0, by the way. And we have one here. Okay. One last thing to change, guys, is this. If you remember, the original object name was process, and after the splitting and merging, it became P. So you have to change. You have to look also for a process and change it to P. So here it is. Change that to P. Okay. So let's save that. And let's take the hint from here and compile it. So here it is, terminal. No such file or directory. Fine, we go to desktop and let's hit the compile. So we have a problem here. Undeclared identifier is reported only once for each function it appears in. So what do we have? We have the semicolon in here, we forgot them. Save, back. Okay, ls, so challenge. This is the compiled file. Let's now upload that to the web server of the machine. And if everything was set up correctly, we're going to receive this shell. So let's see here. Okay, upload the file. What happened? Try again. What happened here? Let's see. So it didn't work. Let's go back to the code and see what we have to change. And as you can see, we haven't received any connection from here. Let's get back to the code. Remove this version. Let's see here. So it is something I think has to do with the dynamic loading. So basically, let's make sure that we have changed all of the pointer names to match the ones in our code. So basically here, WSA startup has been changed, WSA socket has been changed, my init address, this one. So it should start with my, and we have htons. This one also should start with my. Let's look for these occurrences and make sure they have all changed. Okay, so only one in the code. Okay, so let's save now. Delete the old one. Okay. Upload again. Let's check out the terminal. And yep, we received the shell. So now let's navigate to the administrator directory, see the users. Okay, see the administrator. And here we display the content of the flag. So this was the last flag of this room, guys. I hope you found that helpful and useful. And I'm going, guys, to summarize all of the obfuscation notes. I'm working on that to create a new node file for antivirus evasion, still in progress. I will release that shortly as part of the channel membership. So thank you for watching, and still, if you have figured out the signature identification, kindly put that in the comments. I haven't still figured this out yet. So see you in the next video.